Hello friends, this is Kailash, Physics Chemistry, Kendriya Vidyalaya Pasighat. It's my second part of video, that is magnetic properties of the solids. In the first part, I have already discussed electrical properties of the solids. Now, in the magnetic properties of the solids, I am going to discuss the different types of substances or solids based on the magnetic properties. Okay, first of all, you have to know that what happens when a substance is placed in the magnetic field. As all of us know that every matter is made up of small particles that are known as atoms. Each atom is having in its center atomic nucleus, and electrons are revolving around the nucleus. Electrons is having two types of motion. One is spin motion, second is orbital motion, that is around the nucleus. These two types of motions produces magnetic field or magnetic moment. So electrons can behave as tiny magnets. Based on the interaction of magnetic field of the electron to the external magnetic field, the solids can be classified into 5 categories. First one is paramagnetic substances or paramagnetic solids. Second is diamagnetic. Third is ferromagnetic. Fourth is antiferromagnetic. And fourth is ferrimagnetic. Okay, this is the alignment of magnetic moment in the presence of external field. Okay, first part is paramagnetic substances or paramagnetism. These are the substances which are weakly attracted by the magnetic field. They are magnetized in the magnetic field in the same direction of the applied magnetic field. They lose their magnetism in the presence of magnetic field. This phenomena, that is paramagnetism, is due to presence of one or more unpaired electrons, which is necessary for the paramagnetic behavior. Those substances which are having unpaired electrons are in its ground state or in excited state are called as paramagnetic substances. For example, oxygen, titanium oxide, copper 2 positive, iron 3 positive, chromium 3 positive. As chromium is not a solid, then why I am taking oxygen here? Because of its exceptional behavior. As oxygen seems to be diamagnetic due to even number of electrons, but when we see molecular orbital theory of the oxygen, that is molecular orbital diagram, then it is very clear that oxygen is paramagnetic. It is having unpaired electron in its antibody molecular orbital. Next is diamagnetic substances. It's the substances which are weakly repelled by the magnetic field. Paramagnetic substances are attracted and diamagnetic substances are weakly repelled by the magnetic field. Water, titanium dioxide, NaCl, benzene are some typical examples of the diamagnetic substances. Remember, titanium oxide is paramagnetic while titanium dioxide is diamagnetic in nature. These are weakly magnetized in the magnetic field in the opposite direction. This phenomena is shown by the substances which are having paired electrons and they are not having unpaired electrons. The pairing of electrons cancels their magnetic moment and hence they lose their magnetic character. Next is ferromagnetism. Some substances like cobalt, nickel, gadolinium, chromium dioxide are very strongly attracted by the magnetic field. Besides strong attractions, these can be permanently magnetized. As we know that in the solid state, the metal ions of the ferromagnetic substances are grouped together into small regions called domains. We know that in the case of conductors or metals, positively charged kernels are there and free electrons are there. So these positively charged kernels and the electrons generate magnetic moment. These align themselves into a small regions called as domains. Thus each domain acts as a tiny magnet in an unmagnetized piece of ferromagnetic substance. The domain are randomly oriented. When no external field is applied, then domains are arranged in random manner. They are not properly arranged. Now when external field is applied, then their magnetic moment arrange themselves in the direction of the applied magnetic field, and hence they are strongly attracted. Even when magnetic field is removed, then these domain tend to remain in the state of this ordered state of the magnetic field or magnetic moment. So these become as permanent magnets. Next is AntiFerromagnetism. Some substances like manganese oxide show ferromagnetism. In case of antiferromagnetic substances, the magnetic moment in the domains are oppositely oriented and cancel out each other's magnetic moment. So when external magnetic field is applied, these are weakly repelled. Next is ferromagnetism. These are very important solids. Ferromagnetism is observed when magnetic moment of the domain in the substance are aligned in the parallel and in anti-parallel direction in the unequal numbers. They are weakly attracted by the magnetic field as compared to ferromagnetic substances. Magnetides, magnesium ferrite, zinc ferrite are typical examples of these substances, ferromagnetic substances. When these substances are heated above a particular temperature, that is known as Curie temperature, then these substances become as paramagnetic substances, means they loses their magnetism. As you can see that in the diagram given below, ferromagnetism, when external magnetic field is applied, then the magnetic moment are aligned in such a way that they are in parallel and in anti-parallel directions in unequal numbers. This was all about magnetic properties. Now some important questions based on electrical and magnetic properties of the solid. Both parts I am including. Okay, which of the following arrangement shows schematic alignment of the magnetic moments of antiferromagnetic substances? 4 options are given. In the antiferromagnetic substances, what happens? In antiferromagnetic substances, the alignment of magnetic moment is in parallel and in anti-parallel direction in equal numbers. So option will be 4. The next question, which of the following oxide behave as conductor or insulators depending upon the temperature? First option is titanium oxide, second is silicon dioxide, third is titanium dioxide, fourth is magnesium oxide. Right option is third, titanium trioxide. Okay, next one is, which of the following oxides show electrical properties like metals? First option is silicon dioxide, magnesium oxide, sulfur dioxide, and chromium dioxide. Right answer is chromium dioxide, option 4. Now question number 4. To get a n-type semiconductor from silicon, it should be doped with a substance with a valence, option 1, 2, 1, 3, 5. Right answer is option 4, it is 5. Next question. A ferromagnetic substance becomes a permanent magnet when it is placed in a magnetic field because all the domains get oriented in the direction of magnetic field, all the domains get oriented in the direction opposite to the direction of the magnetic field, domains get oriented randomly, domains are not affected by the magnetic field. Right answer is 1. All the domains get oriented in the direction of magnetic field. Next question. What would be the nature of solid if there is no energy gap between valence band and conduction band? If valence band and conduction band are merged together, then what will be the nature of the solid? Right answer is conductors or metals. Okay, question number 7 is same to 6. Question number 8. Write the type of magnetism observed when the magnetic moments are oppositely aligned and cancel out each other. This is antiferromagnetism. 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 Question number 9. How may the conductivity of an intrinsic semiconductor be increased? Means how can you increase the conductivity of intrinsic semiconductors like silicon or germanium? Right answer is by doping. Okay, this is assertion and reason type questions. 4 options are given there. First 2 statements are given. One is assertion, second is reason, and 4 options are there. First option is assertion and reason, both are correct statements, and the reason is correct explanation for the assertion. Second is assertion and reason, both are correct statements, but reason is not correct explanation for the assertion. Third option is assertion is correct statement, but reason is wrong statement. Fourth option is assertion is wrong statement, but reason is correct statement. Now question is statement 1, that is assertion. Semiconductors are solids with conductivities in the intermediate range from 10 to the minus 6 to 10 to the power 4 ohm inverse meter inverse. And reason, intermediate conductivity in semiconductor is due to partially filled valence band. Okay, assertion is right because conductivity range of the semiconductor is 10 to the power minus 6 to 10 to the power 4 ohm inverse meter inverse. So correct, but reason is not correct here because reason for the conductivity is due to small energy gap between valence band and conduction band. So right answer will be option 3. Assertion is correct statement, but reason is wrong statement. Okay, next question is account for the following. Fe3O4, that is magnetite, is ferromagnetic at room temperature but becomes paramagnetic when heated above 850 Kelvin, because 850 Kelvin is the Curie temperature for the magnetite. Means its alignment get disturbed, and hence alignment of the magnetic moment get disturbed, hence it loses its ferromagnetism. Second is Si doped with the gallium is having more electrical conductivity than silicon. Answer is because as silicon is doped with the gallium, so it is an extrinsic semiconductor which is having more electrical conductivity than intrinsic semiconductor, that is silicon. Next one is explain the following with suitable examples. First one is ferromagnetism. Is a phenomena in which substances are strongly attracted by the magnetic field. Examples are cobalt, nickel, iron, gadolinium, chromium dioxide, etc. And these substances are permanent magnets. Next one is ferromagnetism. These substances in which magnetic moment domains are aligned in the parallel and in anti-parallel direction in unequal numbers. These lose their magnetic moment or their magnetism when heated above a Curie temperature. Examples are magnetite or ferrites. Third one is 1216 and 1315 group compounds. These are type of semiconductors formed by the combination of group 12 and group 16 elements. In case of 1315 group elements, cation of group 13 is taken and anion of group 15 is taken in order to increase the conductivity of the semiconductors. Examples of 1315 compounds is indium antimony, aluminum phosphide, gallium arsenide. And examples of 1216 compounds are zinc sulfide, cadmium sulfide, cadmium selenide, etc. Okay friends, this was all about electrical and magnetic properties of the solids. Thank you. Have a nice day.